Now, let's explore key elements that challenge the contemporary claim of a spinning globe by presenting real-world examples that clearly demonstrate a flat and stationary Earth, rather than one with a 25,000-mile circumference spinning on an axis. Let's recognize the universally accepted method for calculating the line-of-sight distance to an object before it disappears over the horizon due to the Earth's alleged curvature, based on one of Pythagoras' theorems. The upcoming real-world Earth curvature calculations we will be performing can be calculated using the online tool here. Applying our Earth curvature formula to the following examples, we will check whether the outcomes we anticipate align with observations one would expect if the Earth is indeed a globe of the reported dimensions. This formula is officially used and endorsed by NASA and the scientific community. No prior knowledge of algebra or spherical trigonometry is required using the online tool. Real-world test number 1. From the vantage point of Apple Pie Hill in the New Jersey Pine Barrens, 40 miles distant, the Philadelphia skyline can be seen in its entirety. Taking into account the 211-foot elevation of an observer from Apple Pie Hill, calculations of the Earth's curvature posit that the skyline should be obscured and not visible by 329 feet below the horizon. However, contrary to the expected calculations, the skyline is in full view. Real-world test number 2. From Bear Mountain in Harriman State Park, situated 60 miles away, one can easily see the New York City skyline. According to the curvature of an Earth with an 8,000-mile diameter, the skyline should be hidden from view by 174 feet of curvature when observed from Bear Mountain's summit, which stands at 1,283 feet. Despite this, the skyline is fully visible. Real-world test number 3. On days with clear visibility, it is possible to see the complete Chicago skyline down to street level from Grand Mere State Park across Lake Michigan, a distance of 59 miles. According to standard Earth curvature calculations, this view should be entirely obstructed by 2,091 feet of Earth's curvature. Real-world test number 4. In Genoa, Italy, standing 70 feet above sea level, one can see the island of Gorgona, which lies 81 miles distant. Under the expected calculations, this island would be obscured entirely from view by 3,338 feet. Scientific attempts to debunk these findings often cite atmospheric refraction as a factor influencing observational outcomes in our previous examples. However, the impact of atmospheric refraction on visibility calculations is quite minimal, typically amounting to only a few % of difference. This slight variance is far insufficient to overturn our conclusions supporting a flat Earth model, in exchange for adopting a spherical Earth model. While countless other real-world observations supporting a flat Earth are abundant, the particular technique provided previously serves to highlight key verification approaches that support our assertions of a flat rather than spherical Earth. Guglielmo Marconi's historic radio test transmission occurred on September 22, 1930. The Italian inventor successfully sent a wireless signal from Poldhu, Cornwall, in the United Kingdom, to Sydney, Australia, marking a significant milestone in the history of radio communications and demonstrating the feasibility of transmitting radio signals across vast distances. During the test, Marconi employed high-power radio equipment and sophisticated antenna systems to span approximately 12,000 miles. The reception of these signals underscored the potential of wireless technology to connect disparate locations worldwide. Marconi's radio test transmission to Australia played a pivotal role in advancing the field of wireless telegraphy and laid the groundwork for future developments of worldwide communication systems that we rely on today. This experiment significantly contributed to the advancement of radio communication technology and understanding, eventually leading to more regular and reliable long-distance wireless worldwide communication. Using the official Earth curve calculator, the calculation determined that, based on a spherical Earth model, the receiving antenna in Australia would have to be approximately 7,893 miles below the horizon. This prompted me to investigate the feasibility of such an extremely distant radio transmission scenario using an AI chatbot based on a spherical Earth model. Question: can you envision a scenario where a radio signal could be transmitted and received successfully despite being 7,893 miles below the spherical Earth's horizon? Answer. The concept of a radio signal traveling 7,893 miles below the horizon of the spherical Earth is far beyond the capabilities of radio signal transmission for this distance. The curvature of the Earth poses a physical limitation on the direct line of sight for radio signals. As the Earth curves, objects or signals beyond the horizon are not visible or receivable due to the obstructed view. While techniques like antenna height, signal amplification, and atmospheric conditions can extend the range of radio signals to some extent, they cannot overcome the fundamental limitation imposed by the Earth's curvature, especially at distances this remote.